Hello everyone, and welcome to the Kusto Query Language crash course. In this video, we're going to cover a wide range of topics. We're going to start by learning about Kusto Query Language and how you can use it inside Azure to query different data sources. In the following part, we're going to learn about Kusto Query Language syntax. We are also going to cover 80% of the operators that you'll ever use, so by the end of this module, you will be able to craft a wide range of queries that you can use on a daily basis. Later in this video, we're going to cover some advanced topics, such as data aggregation and visualization. Also at the end, we'll share how you can export data and share queries with your teammates. So what is Kusto Query Language? KQL is a query language that's developed by Microsoft and is designed for querying and analyzing large datasets using the Kusto engine. And mainly it's used within some of the Azure products, such as Azure Monitor, Azure Data Explorer, and Microsoft Defender products. And it's optimized for interactive ad hoc queries over structured, semi-structured, and unstructured data. It's worth to mention that Kusto Query is a read-only operation against Kusto cluster ingested data, and queries will always run in a context of a particular database in a Kusto cluster, and we will refer to this one as a data source throughout this course. First, let's explore Kusto Query Language syntax. KQL is designed to help users to query and analyze data efficiently, especially where time series data and structured information are involved. Mainly, it's optimized for working with large datasets and time-based data. So let's break down the key components of KQL syntax. First, we start by specifying a data source. Typically, you start your query by referencing a data source, which could be a table or datasets where your data is stored. In most of the cases, you will start by referencing a Kusto cluster, Kusto database, and a Kusto table where your data is stored. Following the data source is a pipe characters, and pipe characters are used to chain operations together in KQL. The output operation becomes the input for the next, and this allows you to perform a sequence of transformation for the data. For example, where log level equal error. Next, you specify the data aggregations, and in this scenario, we are going to use summarize operator. And it's used to aggregate data and perform calculations like counting, summing, averaging. And in this example, we're doing summarize count equal count by number of messages. Next, the projection. The project operator allows you to choose a specific columns to be displayed in the query results. This is similar to the concept of selecting columns in SQL. For example, we are projecting the messages and the messages count. One of the most important parts of writing a Kusto query language is the time range. KQL often deals with the time series data. The range operator is used to specify a time range for your query. For example, where timestamps larger or equal a day ago. Putting it all together, here is a simplified example of a Kusto query language combining these elements together. Remember that KQL is a highly flexible and can be adopted in various data analysis and exploration scenarios, especially when working with a time series data and large datasets. In this part, we are going to take a tour inside the Azure Data Explorer Portal. And as I mentioned in the introduction, there are many platforms inside Azure that's using KQL as the query language. So we'll start by learning about the Azure Data Explorer being one of them. The user interface for the other platforms may differ from the Azure Data Explorer, but be assured that the KQL language is identical for all of them. This portal is publicly accessible, so no Azure account is required. And you can access it by going to the URL you can see on the screen. Inside the Azure Data Explorer portal, the main part that we're going to focus on for this video is explore sample data with KQL. Inside explore data samples, we are going to select basic data. During our session, we will be using the storm events table. This is a sample database, so feel free to use any other dataset. And to give a little bit of context, the storm event database contains some records and various types of severe weather as collected by the National Weather Service. So let's familiarize ourselves with a query editor. We usually start by adding a Kusto cluster to execute our query against. In this one, we can see I have added a Kusto cluster that's called help. And if you click on the edit, you can see it's called help.kusto.windows.net. The next part are the databases inside the Kusto cluster. Here we can see several databases such as Contoso Sales, Find My Partner, and what we're going to focus on is this sample database. Over here, the main table that we're going to write our query against is called Storm Events. If you clicked on Expand for Storm Events table, you can see information about all of the columns inside this table, such as start time, end time, event ID, state, and so on. Let's start by writing our very first Kusto query. First, you need to make sure that you're selecting the correct Kusto cluster and the correct table. Next, let's type the data source that we're going to execute our query against, and let's start by writing the table name, which is storm events. And immediately you can spot one cool feature of Kusto Editor, which is the IntelliSense. So once you have typed the pipe character, you can see all of the possible options that can come after the pipe character. We are going to start by just specifying the table name and hit run. There are two ways you can execute the Kusto queries, either using Control Enter or by writing on run. This one is going to take a long time because we are querying against all of the data inside the storm events, so it's expected to take that long, and you can see we took 8 seconds to execute this query. Here you can see that we have the returned options of this query, and we can see several columns and rows. We have around 60,000 records, and we can see all of these information that's retrieved. Sometimes it's useful when you have like a small table or a small dataset, but later we're going to explore how we can filter these data so we can get the specific information that we're looking for. Because usually when you're writing your Kusto query, it's against a large datasets, and it's not that helpful and useful to run and retrieve all of the information inside that table. So the first Kusto operator for this video is the search command. The search command allows you to search for any keyword inside any datasets that you have within your Kusto cluster. For example, for this scenario, we're going to search for Wisconsin inside the storm events table. And if we click on run, it's going to look for all of the data inside the storm events. It's going to search for a keyword that's Wisconsin throughout all of the data sets that we have over there. So the results of this query is going to be every single record that we have inside the storm event that contains Wisconsin. And it's worth to mention that search is not a key sensitive by default, but you can make it a key sensitive operator. In the following query, we are searching for Wisconsin with kind equal case sensitive. It means that we are going to look for the exact match for the Wisconsin upper letter inside this table. So let's execute this query. After executing this query, we can see that we have around 1,850 records, where in the first one we had around 2,000 records. And the main reason for this difference is the case sensitivity between these two operators. So whenever you're executing your queries, you need to make sure that the case sensitivity is important for your query or not. In the beginning, we have mentioned you start writing your query by specifying the data source. But that's not like the case for most of the queries. For instance, in this scenario, we're searching for Wisconsin. What exactly this is going to happen? we are going to search for Wisconsin across all of the tables that we have inside this Kusto cluster. This is not a good idea because it might take a very long time if you have a large dataset. So you need to be careful whenever you're working with or writing this type of queries. To view the results of this query, you can just expand the results that we have here under the records. So for instance, we have results inside the table set called COVID-19 Bing. There are lots of data over here, and one of the states is going to be Wisconsin. So there's the Wisconsin that we're searching for. One way we can improve this query is by limiting the number of tables that we're searching against. So in the following example, we're doing search in, and we are specifying the name of the tables that we are looking for. So for instance, we're specifying the storm events and the COVID table. And we are again searching for the keyword that's called Wisconsin. And let's hit run. Results of this query is going to be any records that we have inside these two tables that contains the word Wisconsin. The following example is more of a real-world scenario. So inside this example, we're going to search inside a specific column for an exact value inside a specific table. So we're specifying the table, which is the storm event, and we are searching for all of the records inside a column called state for an exact value that's called Wisconsin. Let's execute this query. So here in the results, we can see that inside the state column, all of the results should exactly match the word that we were looking for, which is Wisconsin. So here you can see like we have around 1,850 record. Two useful operators that we can also apply for searching is starts with and ends with. In this example, we can see we have a search star, and star is like an asterisk sign, so it's looking for all of the tables inside the storm events, and it's looking for any text where it ends with Wisconsin, and in the first one it's looking for where it begins with a Wisconsin. So we can start with this one. Let's execute it. The search operator is very useful during the data exploration phase. In this part, we're going to learn how you can limit the results of your query based on conditions. In this example, we're going to learn how we can use conditions to limit the results of our queries. In this example, we're starting by specifying the name of the table, which is the storm events, then the pipe characters. Then we are specifying the where keyword and specify a name of a column, which is equal a specific date time. So what exactly we're doing is we are searching inside the storm event table, and we are looking where any record that match the following condition, and the condition is the start time must exactly match the date time that's provided. Let's run this query. The result of this query is going to match what we have in our query. So we can see the start time is an exact match, and we have around 25 records. So if we specify the results, we can see that we have selected the start time. It's exactly as specified, and we have the rest of the data. So this could be kind of targeted into more targeted scenarios for data analysis. So you can take it as an example inside your Azure environment. So you're looking for an event that happened during an exact hour. So you can do where start time equal a specific date time that you're suspecting that the issue started. So over here, let's take an example where we want to filter the start and end time. So we start by specifying the pipe character, and we do where start time larger than or equal. One nice feature in Kusto is that, for instance, you're looking for this specific date, so you just point your cursor where you want to place it. You do right click and you do the following. Let's try to find it. Where is it? Add selection as a filter. So it's actually adding the filter automatically for you. We're not looking for this specific time, usually this larger or equal the start time. And you can do something like and, or any other logical operator, but like we're looking for a specific time frame. So we're doing and end time and time equal, and we do something. Also, this is a cool feature. You just copy this one and do, oh, actually it's not. Let's do add as a filter as well. So you're going to do datetime less than or equal to this specific datetime. So let's try to execute this query. Over here we have like a subset of the results. So what if we want to look for more detailed or more conditions? What we can do? Let's try to look for the dataset. So let's say we're more concerned where the end location of the storms. End location is Washington. Let's add this one as a selection. Let's execute the query. Over here we can see one exact row, like we have one record. Let's try to find something else so we can do actually more conditions. So let's say we are actually concerned about all of the events that happened in Indiana. So let's add this one as a filter. Let's execute it. We have 40 records. Let's say we're looking for let's see what exactly we're looking for. Let's say where the damage property is over 5,000. So we do where damage, and IntelliSense is pretty cool over here, larger than or equal to 5,000. Let's execute it. So we have all of these events, and we can see, for instance, it's all floods, and we can see the source, where exactly we're getting this information from, the begin and end location, and so on. So this could be super useful whenever you're writing queries against a data for instance, a virtual machine or a web app, and you're looking for more detailed information. So for instance, you're looking for events that started during this time. You're looking for a web app that's called, for instance, in this case, Indiana, and you're looking for server errors where it's like anything larger or equal to 500 HTTP status code. One more very useful way we can limit the datetime for our queries is using a Go keyword. So in this one, we start by specifying the table name, then where start time or end time, depends on your scenario. It could be the time frame, larger or equal ago, and we can see that we have ago and a time span. And inside this time span, usually you pass days, hours, minutes, seconds, and so on. One thing that's very useful inside Kusto Query Explorer is that it gives you some examples. So for instance, over this one, we're going to pass either a day, hour, minutes, and we can say, for instance, 1 day or 1 year or 1 day, for instance, over here, and we're going to execute a query. But it's worth to mention, like, I don't have anything that happens in the past day, so we don't have any results. So let's do some like I don't know, more kind of a larger time frame. It's like since I don't know, a very long time, but at least to get back a results. Some results over here. Again, we don't have any results. Oh, actually we do. Nice. So we're getting, I think, most of the records, which is nice. So in this one, for instance, in a real world scenario. So for instance, some issue that happened in your Azure environment, and you're looking for anything that happened in the past hour, let's say. So you do ago 1 hour, anything larger than 1 hour. So for instance, the current timestamp that we have, let's say it's 5 p.m. We're looking for anything that happened 1 hour ago from now. It's worth to mention that the ago allows you to search for a relative date range, right? So if you're searching, if you're sharing this query with one of your colleagues, they're not going to see the same results if they're viewing, if they're running the queries after an hour from now, because it's relative. So it's going to look back for a previous hour from the time that they're executing their query. It's good for data exploration, but when you're searching a query, when you're sharing a query with a colleague, you need to do kind of like an exact time. So for instance, you start by doing a go 1 hour, and you found out that the issue happened at, let's say, 5 p.m. exactly. You do where timestamp larger or equal to 5 p.m. and less than 5:10. So it's going, for instance, to search inside a 10-minute time span or 10-minute time frame. This is really important when sharing a query with coworkers. For instance, if you're doing investigation using Kusto queries. Here you can actually start writing more advanced queries to look for a specific scenario or a specific event that happened within your environment. So how we can build on top of that. So we start again by specifying the data source, then we specify the time frame. But for instance, if we run this one, we can see like I think we have 25 record. But like, what if I need to specify more conditions? I need to search inside. I need to search inside the states if it's New York or it's Colorado, right? So for instance, over here we're saying in Azure environment we're saying we are searching for a virtual machine or an app service that's called AB, or an app service that's called C. So we're doing this search and we're getting back results. So it's kind of like limiting. So we can see we have only one record. So this one would actually have the information that we're looking for. In the next part, we're going to cover the take operator. This is also targeted for data exploration phase. So for instance, you have a table and you just want to have a glimpse of the data within this table. So for instance, this is my first time exploring the storm event, and I just need to see what exactly inside this table. So I'm doing like take 10. The take 10 is going to give me 10 random records or 10 random rows from my storm event table. So over here, it's just like some sample data. You can consider some sample data. It's useful just like to explore and see what exactly within your Kusto table. In this example, we're going to combine the take operator with the other language operator. So we start by specifying the data source, which is this table, the storm events. Then we do our conditions. And for the conditions, we are doing where the end time equal this exact date time, the state where it's equal New York, and we are actually taking 5 records. It's worth to mention that it's not guaranteed to return 5 records. So for instance, if the output of this query is only 4 records, it's going to do like kind of a best effort and return 4 records as well. So depends on the results of the actual query. It's going to see, does it actually match the condition of taking 5? If it matches the condition of taking 5 or exceeds it, it's going to return 5 records. If it's less, it's going to do like a best effort and return the records that it found. In the next operator, we are going to learn about some data aggregations. And in this example, we're learning about count, and it's just going to count the number of records that match a following query. For instance, we're doing a query against this table, and we're doing pipe and the count. So what's exactly it's doing? It's doing a count of all of the records that we have inside this storm events table. So let's execute it. And we can see the total count of number of records that we have within this table. You can combine the count with other filters and operators. So for instance, we're looking for count of events that happened during this condition. And this condition happened to be where end time equal this specific end time. Let's run this one. We can see there were 15 events that happened during this day. One more useful data aggregator is the summarize operator. So for instance, over here, the summarize operators allow you to count number of rows by column using the count operator. So what we're doing over here, we're doing a summarize over count by states. So what we're doing is we're going over all of the data that we have inside the storm events, and we see how many records we have per state. So if we're executing this one, it's going to show us we have around 4,000 for Texas, 3,000 for Kansas, and so on. We can break down by multiple columns, such as the state and the damage property. Let's execute this one. So this one's going to show us how, like, for each count, how many damaged property we had. So for instance, for Florida, we had 0 damage property, and there were like 842 records, and so on. This is useful, for instance, where you have an environment, you have a virtual machines, and there are faulty virtual machines within your environments. You're doing count by VM name and, for instance, server errors. So it's going to show you like a summary of number of errors that happened over your virtual machines over a specific time if you are passing a condition. For the next operator, we're going to talk about the bin operator. So the way we use bin is to allow you to summarize the records into logical group like days, server errors, 400 errors, application errors, and so on. So for instance, over here we are doing summarize for a number of entries by a bin, which is like a time frame, 1 day. So it's going to look for each and every day, and it will count how many events happened during every day. So for instance, let's actually go back over here. Sorry, let's sort it by descending. So for instance, we can see over here during this specific day, we had over 1,000 events. So it seems like a very bad day in terms of weather, because there were lots of events that happened during this day. If you want to match it to a real world scenario, you can do summarize for a number of server errors by VM name. So you can see which virtual machine had most of the errors, or server errors, or 400 errors, and so on. So this is like one way you can use the bin. Also, you can do it like by multiple levels. So you can do summarize number of entries by state and the time frame bin to 1 day. Of course, you can change like the start time to, for instance, end time or any time frame selector, and as well over 1 day you can specify any time frame as well, like 1 minute, 1 second, 1 hour, and so on. So over here we can see, for instance, on Kansas, on 5th of May, we can see we had over 100 events that happened during this day, or at least 100 record. So we can have an idea of what exactly happened during a specific or more specific time frame. In the next part, we're going to talk about the extend operator. The extend operator is used to calculate columns and add the result to the result set. So for instance, in this example, we are searching for inside storm events table, we're searching for state equal New York, and we're doing an extend, and we're calculating a new property that's called damage, and it's defined as damage of the property over 1000 multiplied by 10. If we are executing this query, we can see that it will extend a new column for us that's called damage. It will depends on like the actual calculation for this one for each record, but think of it in a real world scenario. For instance, you have a data disk for your virtual machine. Currently the data is stored in megabytes. You're looking to convert it, for instance, to gigabytes. So you're doing, for instance, the megabytes over 1024, and you're actually extending the size to gigabytes. This is like one use case of using the extend. In this example, we're going to talk about a way you can create a new string column using the string concatenation function. So for instance, in this example, we have the storm event table, and we are extending a new column that's called object counter, and it defines as equal to string concatenation of state hyphen to end location, and we are only taking a limit of 100 record. Let's execute this one. So let's take a look at the results of the query that we have created. So over here you can see the object counter, the new column that we have created, and the value of this column is the state and the end location. So we can see like we are only taking 100 record as per the limit. We have mentioned earlier that you can use projection to limit the number of columns that you want to view as a result of your query. And the way to do that is using the projection keyword. In this example, we're selecting the storm event table, we're doing a project, and we're specifying a set of columns that we want to view as a result. So if we are actually executing this query, and just to make it a little bit faster, let's do a limit by 10, and let's execute this query. So over here we can see we are getting 10 records, and for these 10 records we are only viewing the columns that we have selected after the project keyword. Projection is very useful. Sometimes Kusto tables could contain hundreds and hundreds of columns, and you want to look specifically inside a specific set of columns. So using the projection could limit the number of data that you have to go through to troubleshoot or to analyze an issue. In the next example, we're going to see how you can combine both project with extend. In this example, we're selecting the data source, then we're doing some conditioning. So we're looking for where state contains Ohio. Then we're only concerned to return the result for the following columns. So we are only concerned for this one, but we are also extending the results and doing some calculation. We're doing a calculation for the damage, and it's set as the following. So that we are expecting to get the results out of this one, which should be all of these columns and one additional column which is called damage, and its calculation as follows. So you can combine both project extend in a single keyword, and in the following example we can see that we don't have extend, but project can actually simulate the extend property. So over here we are doing a project, we're getting the following column, and we are doing calculation of the damage. So if we're doing and getting back the results, we're going to see the storm summary and the damage calculation. So it's up to you whether you want to combine both keywords or use it as a separate. So in this example, we're going to learn about a variant called project away. So we will project all of the columns except the one listed. So for instance, in this one, we're doing a project away, begin lat and begin location. When we run this query, we're going to get a result of all of the columns except these two. In this example, we're going to learn about distinct keyword. So the distinct keyword is going to return a list of deduplicated values of columns from the input dataset. In this example, we're looking through the storm events, and we're doing a distinct state. So it's going to return a deduplicated values of all of the states that's mentioned inside this table. In the next example, we are going to learn about the top operator. The top returns the first n number of rows of a dataset when a dataset is sorted by the by clause. And in this example, we're doing a storm. We're getting the top 20 records by start time, and we're doing descending. So if we're running this query, we can see we are getting 20 records, and we are seeing that we're getting the top 20 that is defined to the start time. So like these are the first records that we have in this dataset, or the first 20 records that we have in this dataset. A picture is worth 1,000 words. In this part, we're going to cover Kusto virtualizations. Kusto virtualizations is just a virtual representation of data inside, obtained from KQL queries. It translates queries into charts, graphs, and tables, and it's very helpful when we're doing data analysis for a large dataset. There are lots of virtualizations we can use in Kusto. There are multiple types, such as area chart, bar chart, column chart, pie chart, scatter chart, table, and time chart. In this example, we're rendering a column chart, and the query syntax is as follows. We're starting by specifying the data source. We're doing some data aggregation. We're doing the summarize events were count by the state. We're concerned only when the event count is larger than 10. We're doing projection. We're only concerned for the state and the event count columns, and we're rendering the column chart. So after executing this one, we're getting a column chart where we have the state name and the total event count. In this example, we're rendering a pie chart. And to do that, we're starting by specifying the data source. Then we're doing a summarize of state count by the name of the state. Then we're doing a sort by the state count. Then we're doing a rendering of a pie chart. And the title of this pie chart is storm events by the state. So over here we can see from this graph that the state with the most events is Texas over here. We can do something like take, for instance, 10, so we can make it more clear. Over here you can see, for instance, we are taking only 10 examples, and you can see like this visual representation of number of storms by state. At the end of this video, it's very useful to learn how we can share queries with other coworkers, because usually whenever we're doing troubleshooting, it's very useful to keep a record of the queries that we have run against our data, and also to share it with our teammates. So taking an example of this simple query, for instance, we want to share the query and the results with one of our coworkers. One way you can do that is go over the copy, and we have an option to do link to the clipboard, or link and query to clipboard, or link query and the result to clipboard. I usually prefer to do this one. So whenever you do this one, you can see you have a link to this specific query, and also you can see what exactly is inside this query. So if you're sharing this one with one of your colleagues and they will get this URL, they will click on it and they will have this query to be able to run against the Kusto cluster and the Kusto database. One useful way is also to export the data, and over here you can see like the options that you have to export the data. So you can click on download, and over here you can download the actual Kusto Query Language or the actual query that you have run. One way you can export the query to Power BI, export it to Excel, or export it to CSV. To summarize this video, we started by an introduction to Kusto Query Language and where it can be used inside Azure, Kusto Query Language syntax, and also we took a tour on Azure Data Explorer Portal and we saw the Query Explorer and how you can write your own queries. We covered 80% of the operators that you will use on a daily basis. We have discovered how you can do data visualization with Kusto, how you can export data and share queries with your coworkers. In later videos, we're going to learn how we can apply the knowledge that we got from this video and apply it to your Azure resources. So we're going to start by learning how we can query Azure Resource Graph, Azure Monitor, Azure Application Insight, and so on. So stay tuned. Thanks everyone for watching and have a great day.